Okay, so what we're going to be talking about today is law of cosines. Last 2 days we have spent on law of sines and area of a non-right triangle. So we're going to kind of continue on with that because sometimes we have triangles that don't fit law of sines for us, right? So with law of sines, we were looking for a side and an opposite angle, a side and an opposite angle in order to find a missing piece. With law of cosines, it works a little bit differently. We're not always going to have that pretty setup of opposites. So we need another method to solve for a missing side or a missing angle. And that other method that we're going to use is law of cosines. Okay? So on the next page, just like with law of sines, we have something similar, law of cosines. We do have an equation that is on our reference sheet, a squared equals b squared plus c squared minus 2bc cosine a. That's on your reference sheet. Now, I have it written down two other ways, but is there a difference in the way that I've written them, really? No. The only difference is I've moved some variables around. I don't want you to get stuck in the mindset of what are the variables. I need you to think about where in the triangle are these things placed. Okay, it doesn't matter what the variables are. I could change those to any letters that I'd like. Okay, what makes a difference is that you're putting them into the right spots based on your triangle. All right, so the important thing that you do need to notice is notice this. Okay, this is side A. What do you notice on the other end of the equation? Angle A. Does that happen with every single one of them? Yeah. Okay, so that's the key here. You're going to be setting law of cosines equal to a side if you have the opposite angle, or vice versa. If you have the opposite angle, you're going to set it equal to the missing side. So you have to keep that in mind when we're setting this up. Just like when you guys were finding area of a non-right triangle, what did you guys have to have in order for the area of a non-right triangle to work? Two sides and the included angle, right? Okay, so law of cosines is going to be similar to that. You're going to have two sides, and you're going to be looking for the included angle. You'll have the third side as well in that case. Or you'll have two sides and the included angle, and you'll be looking for the side opposite the included angle. All right, so you're going to see what that looks like in just a minute. Are you guys ready? Good? Okay, so law of cosines, just like law of sines, serves two purposes, finding missing sides and missing angles. Here's our first one. In triangle ABC below, AB is 8, BC is 13, and the measure of angle B is 110. We want to find the length of AC to the nearest tenth. Okay, we want to find the length of AC to the nearest tenth. What's another way that I could name AC, side AC? Lowercase b, good, side B. Okay? Okay, so we have two sides. We have the angle in between, and we're looking for the side opposite the included angle, right? So since we have this set up with the two sides and the angle in between, we're automatically going to go to law of cosines. So we're going to write down law of cosines. A squared equals b squared plus c squared minus 2bc cosine A. And that's right off your reference sheet. Okay. Now, what is side A going to be in terms of our variables? What are we solving for? Side B, okay? So that's what this is equal to. We want to solve for B, okay? Again, do the variables matter? No, you just have to make it work for your triangle. Don't get stuck on the variables being A, B, and C, because is every triangle going to be labeled A, B, and C? No. So don't get stuck on that, okay? So what do you want to call B in this case? 8, sure. And how about C? Good. So those are my two legs, right? So we're going to have minus 2, 8 times 13. There's your B and C. And cosine of 110. So here's your key, right? Here's the angle, here's the missing side. Notice where they are in relation to one another. Opposites, okay? So that's what you're looking for. They're on opposite sides of the equations. They're on opposite sides of the triangle. Got it? Okay, now what? What? Yeah, we're just going to take the square root, right? We know to get rid of a squared, we take the square root of the whole thing. We're going to minimize the possibility of making a mistake by just putting this whole thing in the way we see it. Okay? We can put that in the way we see it, right? That shouldn't be a problem. Oops. Okay, so I'm going to put in the square root of 8 squared plus 13 squared minus 2 times 8 times 13 times cosine of 110. So just the way you see it. And to the nearest tenth we get 17.4. And what kind of sign do I want to use here? Do I want an equals? Approximately. And there we have it. Okay, so pretty simple when you're looking for just a side. Just plugging it in. You've got your two sides, the angle in between. To find your missing side, you just pop it right in. Are we okay with that? Okay. So what happens if we want to find a missing angle? Okay. So in triangle DEF below, DE is 11, EF is 20, and EF is 15, and DF is 20. Determine the measure of angle D to the nearest degree. So here's what I'm looking for. Right, I'm looking for angle D to the nearest degree. Okay, so I've got two sides. I'm looking for the angle in between, right? So I've got my law of sines. What's A in this case? 15. Good. So it's opposite my angle, right? What I'm looking for. So 15 squared equals, what am I going to use for B and C? 11 and 20. Does it matter what order I put them in? No, just make sure that if you're deciding B is going to be 11, that B remains 11 over here. Okay? And cosine of D, which is what we're looking for, right? Okay. Now what? Yep, sorry. Thank you. Pause. What do I do now? Sure, I could square everything. 15 squared is 225, 11 squared is 20 squared is, okay. Now what? Multiply those numbers. Sure, what do we get? 2 times 11 is 22 times 20, which is 440. Good. Okay. That's a start. Now what? Good idea. Let's add 121 and 400. Can I subtract 440? No. No, why not? It's got that cosine D attached to it, right? They're not like terms, can't combine them. Do I want to divide over the cosine? What's my goal? We want to get cosine alone. That's the goal, right? Good. Subtract 521. What you get? Okay. Good. Divide by negative 440. What'd you get? 37 over, thank you. Okay. Good. Take the inverse. Is that to the nearest 10? How did it want the answer? Nearest degree. So what's it going to be? 48 degrees. Good. Now, with law of sines, we had to look for a second angle, right? Do we do that with this as well? No, why not, Stephen? What? Well, but could there be a possibility of a second? Why? The angle would be too large. Keep going. Good. The only place cosine's positive is in quadrants 1 and 4. What do we know about all the angles in quadrant 4? They're 270 to 360 degrees, right? Can you have one of those angles in a triangle? No, too big. Okay, so we're only concerned about one solution for law of cosines, or one angle. Okay? Good. What do you guys think? So finding an angle is a little bit more difficult because you do have to do out the math, but it's not hard. It's just solving an equation. Okay? All right. So a triangle has 3 sides that measure 8, 14, and 20 centimeters. Find the measure of the largest angle of this triangle to the nearest tenth of a degree. Using your answer from A, determine the area of this triangle to the nearest square centimeter. So I want you to work with your group, okay, and I want you to work through this problem. Talk to one another if you get stuck, okay? Try and work it out on your own. All right, so we're looking for the largest angle. Where's the largest angle located? Yeah, across from the largest side. Okay, so tell me how you set up law of cosines. Give me the numbers. Good. Goes cosine of, well, I guess we call it A. Okay, good. Guys, hold on. All right, so the reason we're setting it up this way is because if this is the angle that we're looking for, the side opposite is what has to go on the other end. Okay? Okay, so now what do we do? Okay. Where'd you get 260? Where'd you get 260 from?
Oh, adding 64.
Okay. Sure. What'd you get? 140. You have to show work to get credit for all this. From here to here? Yeah, that's fine. Divide over negative 224. And you get what? Okay, now I want to stop here. We need to think about this. Cosine is equal to a negative 5/8. What does that tell us about the angle? Yeah, it's got to be in the second quadrant, right? I know cosine is negative in the second and third quadrants. Can it be in the third quadrant? No, it has to be in the second quadrant. So I'm going to take the inverse. I'm going to take it of the positive value, and it's going to give me what? 51.3? And that's the reference angle. Right. So to get the angle itself, I do 180 minus 51.3, and that gives me what? Say it again. 128.7. How does it want it rounded? Did it specify? 10? Okay. Good, so we've got the angle. Are we okay with that? All right, so that's part A. Part B wants us to find the area. Okay? K equals 1/2 AB sine C. What two sides have to be used in finding the area? Yeah, 8 and 14, right? Because we have the included angle. Okay? So K equals 1/2 times 8 times 14 times sine of 128.7. Say it again. 43.7 centimeters squared. And it wanted it to the nearest square centimeter. So let's rethink that. Yeah. So K equals 44 centimeters squared. It's an approximation. I apologize. Oops. Should probably put down the pen. Okay? How do you feel with that? Okay, so that's law of cosines. So again, you're using law of cosines when you have two sides. You're using law of cosines to find a missing side if you have two sides and an angle in between. You're using law of cosines to find an angle if you have three sides and you want a missing angle. Okay? Your homework tonight is pages 8 and 9 in the packet. Give it a shot. Tomorrow we're going to move on to trig applications. So we're spending 2 more days on law of, one more day on scratch that. Tomorrow we start a combination of law of sines, law of cosines. We'll spend the next 2 or 3, that's not expensive or anything, 2 or 3 days working on applications. Okay?